2x2 matrix we're calling B, where B is equal to, I don't know, let's do 2, 3, -1, and -2. See what happens. So there's a couple ways to do determinants. There's a way that's kind of interesting and easy to remember. If you know how to draw like the cutesy little fish, that's pretty much what we're going to do. So we're going to go this way, down from 2 times -2, and then when we go backwards, that's going to create a negative. So we have 3 times -1, and that's going to be subtracted from the first value. So what we can do then is we can say 2 times -2, and then minus 3 times -1. And then just math that out really quick. So we get -4 here, and then that's negative and negative, so that's +3, so you get -1. And that's the determinant of B, nice and easy. With 3x3s and bigger, there's more interesting ways. 3x3. So let's call this matrix still B. We'll do, I don't know, let's do 1, 0, 4, 3, 2, 0 here, and then we'll do, I don't know, 5, 1, and 1. Let's see what happens. So with doing a determinant, it's really cool because you actually get to choose where you start on your determinant, and there's a couple of tricks to choosing the easiest path. You can choose any column or any row to do your cofactor expansion with. Zeros are great because that cancels an entire term within that expansion, which is really nice. The other way I like to think about it is I can also try and include 5s in my expansion, or the biggest number you have, just to kind of try and simplify some of the math, the intermediary math along the way. In this case, 4 is also a big number, and we have some zeros here, so either of those expansions will be the most straightforward. I think the one y'all are probably most used to seeing is this top one, so instead of doing that very common version, let's just do this right column. And so I like to circle the expansion that I'm doing just so I can keep a good mental track of it. So now what we're going to do is we're going to take each of these cofactors and we're going to expand it. Now there's something we have to remember is that if we have n rows and m columns, that's really important for figuring out our negative and positives to our coefficients. So let's start here with our cofactor expansion. So we'll start with our 4, and there's always something in front of our 4. So we have -1 times n plus m. And that tells us our even and odd periodicity for our different cofactors. So in this case, our n and our m, for this 4, we have row 1 and column 3. So we have 1 plus 3. And then we're going to write our minor. And we're going to go and do all the steps just to make sure we don't make any mistakes. So when we're doing a determinant, we're actually going to cover up the row and the column of the cofactor we're expanding. So in this case, the 1 and the 0 here will be covered, and the 0 and the 1 here will be covered. So this is our minor here, 3, 2, 5, and 1. Okay, and then because I'm using the -1 with the power, I don't have to try and remember which ones are negative and positive. I can just write a plus in between every one, and then we'll rewrite our -1, and then we'll do our new power. So now we're going to expand on 0. We don't really need to do this because we know it's 0, so everything's just going to multiply to 0, but we're going to go and do it for good practice. And then we have row 2, column 3, so 2 plus 3, that's times 0, so we already know that's going to 0 out, but we'll go ahead and write it out anyways. In this case, we're covering up this middle row in our last column, so we're left with 1, 0, and 5, and 1. And then we'll write our plus again, and then we'll do our -1. Now we're expanding on 1, so this is in our third row in our third column. So we have 3 plus 3, and then we have just times 1, and then our minor. So our minor here, if we're covering up the last row and this furthest to the side column, we have 1, 0, 3, and 2. And now we should have a bunch of 2x2 determinants. So now we can solve this out pretty straightforward. So we'll resolve our negatives and we'll solve our minor determinants all at the same time. So we can write -1 to the 4th power is going to just become positive, so that's going to go away. So we'll just have the minor here, and then we're going to do our fish. So we have 3 times 1, and then minus, because our little eyeball, and then 2 times 5. Okay, and now here we have a odd power of -1, so that one would be negative, so we'd normally write a negative here, but we already know this is all multiplied by 0, so we're just going to ignore that whole term. And then back to this one, we now have -1 to the 6th power, which of course is just going to be 1 again, and then this is 1, so we don't have to worry about that. I did forget something here, my apologies. original cofactor. There we go. Okay, so since this is all just 1 and it's positive, we can do plus, and now we have our fish again with our little eyeball. Then we have 1 times 2, and then minus 0 times 3. And then there's a cofactor of 1 here, so we could write 1 in our parentheses just so we know we actually remember to do that step, but you don't have to. Okay, so now this is going to simplify here. We have 3 minus 10, so that's negative 7. So we have 4 times negative 7. And then here, this 1 doesn't matter, so we're just going to get rid of those parentheses. And we have plus 1 times 2 is 2, minus 0, so that's just plus 2. And then here, negative 7 and 4 should be negative 28, plus 2 is equal to negative 26. So our determinant of b here is negative 26. So 3 by 3s aren't that bad. Now, if you notice, we took our 3 by 3, we turned it into some 2 by 2s, multiplied and added together. Try and make my life easier by designing a problem with an easier 4 by 4, so that way it's a little bit more straightforward to get through. So I think on this one, let's just do 1, 3, 2, 0, 1, 0, 4, 1, 2, 2, just do a whole row of 2s, see what happens. And then, actually I want to change that to a 0. I think that'll be interesting. And then we'll do 3, 1, 0, 0. So, much like earlier, we still get to decide what we're going to expand upon. There's 2 interesting things about these 4 by 4s. These zeros really are your friend, and ideally you either want to try and get 2 zeros together in the bottom of a 2 by 2, or 2 zeros on top of each other on like the side of a 2 by 2, or a side of a 3 by 3. That'll make your life really nice and easy. So for example, if we took, let's assume this was a 3 by 3 just for a second, we would only have, if we took this column or this row, we would only have to do 1 minor expansion, which is really nice. So at least that part of this should make this one a little bit more straightforward. Unfortunately, on the 4 by 4 side, we have a lot of stuff to deal with. But again, we can choose any column or any row. It doesn't have to be one of the ones on the side. So we could choose this bottom row right here and use this cofactor expansion, so we would only have to evaluate 2. Or we could choose this middle column. Both are totally valid. And I actually think both are kind of the same amount of work, so we'll just do this bottom row and just see what happens. Okay, so now we're going to write our cofactor expansion of just this bottom row. I am going to skip the ones that have 0 coefficients just for space, because it's going to take up a pretty good amount of room. And we'll actually start down here this time. So we're going to start with our first coefficient. So first we need our negative 1, and this is row 4, column 1, so you have 4 plus 1, so that one's going to end up being negative, times 3, and then our minor. So this is a 3 by 3 minor, so we're going to eliminate this row and this column. So our 3 by 3 minor that's left is going to be these top 9 numbers. So we have 3, 2, 0, 0, 4, 1, and 0, 2, 2. And then later, we're going to expand that minor as well. And now, since we're being careful about our negatives, we're just going to write a plus in between, and then we'll write our negative thing as again. So we have, in this case, we're going this one right here. So we have row 4 and column 2. So we have 4 plus 2. Our coefficient is 1. And then our minor, we're eliminating this column and this row. This minor is not as nice, so we get 1, 2, and 0. And then we get 1, 4, and 1. And then we get 2, 2, 2. So that minor did not clean up as nicely as the other one did, but that's okay. And then we can do the same thing with these last 2, but of course, since there's 0 as the coefficient, the whole thing multiplies to be 0, so we're just not going to worry about it. If this was the next one we were going to do, we would actually eliminate this column and this row, and then our minor here would have 1, 3, and 0, 1, 0, 1, and 2, 0, 2, which these zeros are really nice, just like these were. And you would get something similar for this last one, where these 2 zeros would be in your middle of your minor. So the next thing we get to do is now we get to deal with, we'll deal with this first minor since it should be pretty quick. So we're going to take just the first minor, and we'll come back and we'll plug it in here as a value. So that's why I'm going to leave some space down here. So our first minor, we can do cofactor expansion anywhere we want, any column, any row. So I think it's easiest if we take the row that has all these zeros in it, or the column, I'm sorry. So I'm going to take this column here. And so that means my cofactor expansion, so I have negative 1, and then I have row 1, column 1 for my 3, so 1 plus 1, and then my 3, and then I have my 2 by 2 minor. So for my 2 by 2 minor, I've got this column's gone, this row's gone, so I just got 4, 1, 2, 2. Okay, and then we have plus, and then our negative 1 again. Well, that's 0, so I guess we don't need to do anything there, and that's 0, so we don't need to do anything there. So this one actually, we just need to do one calculation, which is pretty nice. So we can solve this one out, and then we'll do the next minor as well. So in this case, negative 1 to the second power is just 1, so we just have 3 times, and then we have our fishy, right, with our eyeball. So you have 4 times 2, and the eyeball tells you the next one is minus 1 times 2. Okay, and then that's 8 minus 2 is 6, so we have 3 times 6, which is 18. So now we know our determinant of this inside piece is 18. So I'm going to go ahead and start writing the bottom